this video, we will be discussing about target sum. You are given an integer array nums and an integer target. You want to build an expression out of nums by adding one of the symbols plus and minus before each integer in nums and then concatenate all the integers. Return the number of different expressions that you can build which evaluates to target. So what they are saying is that in the input, we are given an integer array nums and an integer target. Now, in this nums, what we can do is that we can add a plus or a minus before a number, right? So some numbers will remain positive and some will become negative, right? So now when you concatenate all these numbers, basically by concatenation, they means that if I sum up all these values, all the positive, all the negative numbers together, then whatever is the sum, that should be equals to the target. Basically, how many number of ways are there in which the sum of these elements will be equals to target, right? So for every number, we are having two choices. Either keep it a positive number or make it a negative number, right? So if you make this as -1, then in that case, this will be -1 and the sum of all these will be 4. So 4 minus 1 will be 3. This 3 is equals to the target. So this is one of the ways, right? In a second way, you can make this as -1. So again, the sum will be 3. And then in one way, you can make this. In other way, you can make this. Or in the next way, you can make this one as -1. So in total, there are 5 ways for this nums where the sum will be equals to the target. So this number 5 has to be returned as our answer, right? So this is what the question is expecting us to do. So how to solve this? So as I said, for each number inside my nums, I am having two choices, right? What are the two choices? One is that keep it a positive number, or one is that make it a negative number. So in the question, it is mentioned that in the nums, all the elements will be positive always, right? So one choice is keep it as positive, other choice is keep it as negative, right? So if I try to apply brute force and I apply recursion over here to find out all the possible number of ways. So what we will do is that obviously we will take each of the elements from the nums and we will build a recursion tree out of it, right? So let me give the indices. This is 0, 1, 2, 3, 4, right? So first you will keep your I at 0, the index at a 0. Now for this one, you would be having two choices, right? For this one, you are having two choices. One is that keep it a +1, other is that keep it a -1, right? So at this point, your sum will be 0. When you will come here, your sum will be 1. And when you will come here, your sum will be -1, right? And you will go to I equals to 1, right? Now, for the element at index 1, again, you will have two choices here, right? One is make it a +1 and one is make it a -1. And here also you will have two choices, +1 and -1, right? So again, when you will do +1, the sum will become 2, and then you will go to the next index. Here the sum will become 1 minus 1, that is 0, and I will go to 2. And then here also same thing. Then again, here you will have two choices, give a +1 or take a -1. So here the sum will become 3. Then you will go to the next index and then you will go to I equals to 4. The sum will become 4. Like that, you will make your recursion tree, right? So when you reach at the end, basically, when you reach at the end of the nums, at that point, whatever is this current sum, if this sum is equals to the target, then that means, let us suppose that at this point, we have finished our nums and our sum is 3. Although it's not, but let's suppose. So if I have finished all the elements from my nums and my sum is equals to the target, then that means this is one of the possible ways where my sum is coming out as 3, that is equals to the target, right? So whenever I reach the end of the nums and I check that sum is equals to target, so I know that this is one way. So from here, I will return a 1, that I have found one way. So this will return a 1, this will return a 1, this will return a 1, and so on, right? So at each point, there will be something that will be returned, right? So what you can do is that from +1, whatever you are getting, and from -1, whatever you are getting, basically the number of ways, you can sum up those two, right? So when you will come at the starting, when you will backtrack and you will reach at the beginning point, you will be having the total number of ways where the sum is equals to the target, right? So this is how we can solve this problem with the help of recursive approach. But since here, as we know, in our nums, the number of elements are n, right? And for each of the element, in the array, it can be either added or subtracted. So we are having two choices for each of the n elements inside our nums, right? So this will create like a binary tree of recursive calls, right? Where each level of the tree is corresponding to a position in this nums, right? Basically, this is I equals to 0, I equals to 1, I equals to 2, right? And because there are n elements in the array, the depth of this tree will be n, right? Equal to the number of elements in the nums. So the total number of recursive calls will be 2 to the power n, right? So here the time complexity will be 2 to the power n and space complexity will be n because there are n levels. So let's look at the code. So we'll create a helper function. Inside that helper function, we will pass our nums vector, right? And we will pass two things. One will denote the index, that is I, and the other one is that what is the sum right now. So initially it will be 0. And then we also need to pass our target. So this will return us how many total number of ways are there. So we'll return this, right? Let's create this helper function. So this will return us an integer. So int helper. Now this is receiving the nums vector. So vector int nums. Then it is receiving the index, then the sum, and then the target, right? Now inside this, what is our base case? That if index is equals to nums.size. Basically, we have considered all the elements in the nums. In that case, we need to check that if our sum has become equals to target, then return a 1, otherwise return a 0. When sum has become equals to target, we have got one way, right? So we will return 1, otherwise we will return 0. Then there are two choices for the current index. One is that we add. So in this, we'll pass nums comma index plus 1. We will move on to the next index. And in the sum, here we will add nums of index, right? And here the target. So this will return us the number of ways that we get after adding this number. Second, we'll get the number of ways after subtracting this number. So we'll call helper nums comma index plus 1 comma sum minus nums of index comma target, right? And then we can just return add plus subtract, right? Whatever are the number of ways that we are getting from both of these, we will do their sum and we will return it. That's it. Let's run this. So our test cases are accepted. Now since here the time complexity was 2 to the power n, so to reduce the time complexity a little bit, what we can do is that we can memoize this approach. So for memoization, obviously we would need a DP vector, right? Now for this DP vector, if you see, there are two things that are changing in our recursion. One is the index and the second thing is the sum. Then that means we need a 2D DP, right? But if you look at the sum, sometimes we are adding our number inside this, and in some cases we are subtracting the number, right? So it might be possible that in some case our sum becomes negative, right? For example, here we had passed the sum as 0 initially, right? And the example test case that we considered earlier, there we had a 1. So here the sum will become 1 and here it will become minus 1, right? And the indices of a vector cannot be negative, right? So what we will do is that instead of taking a vector of vector, we will take a vector of unordered map, because in a map our keys can be negative, they can be positive, right? So what we'll do is we'll take a vector of unordered map int comma int and we'll name it dp, right? What will be the size of this? It will be nums dot size plus 1, right? Because the vector is denoting the index, right? That is why it is nums dot size plus 1. Then in the unordered map, the key will tell us the sum and the value will tell us the number of ways, right? So now we will pass this dp and in our helper function, we will receive this dp vector, right? And then here also we will have to pass it. Now for memoization, before returning, we also update it inside our dp vector, right? So in the dp, add the index and add the key sum. We will keep this value, right? And then here, before calling the recursive function, we will check that if this sum is already present in the map. Basically, in the dp, add the index, is the sum present as a key? So we will apply dot find sum not equals to dp of index dot end. Then that means this sum is already present. So we will return dp of index of sum, right? So through this, we can achieve memoization because there were sub problems in our recursive tree, right? So why to call recursion again and again? So let's run this. The test cases are accepted. Now here, for each index, we are going to index plus 1, right? And in 1, we are doing the addition of the current index. and in one we are doing the subtraction of the current index, right? So basically it is going for all the indices and then in that with all the sums, right? So see, what can be the range of your sum? This sum, whatever we are passing, what is the smallest value that it can have and what is the largest value that it can have? So whatever is the sum of the elements in nums, so let's suppose that is x, so then that means my sum can at max go to x, right? And my sum can also go to minus x, right? Because we are doing minus also over here, right? So basically the range of my sum can be from minus x to x, right? And I can say that this will be somewhere around 2x, right? So the time complexity of this approach will be n, right? Where n is the total number of elements inside the nums into 2 into the total sum of my nums vector, right? 2 is constant, so we can remove this. So it will be somewhere around n into total sum, right? And same goes for the space complexity also, that it will be n into total sum, right? Now let's try to remove the recursion and let's try to do a bottom up or top down approach with DP. So for that, what we can do is, obviously we will be needing this DP, so this will remain as is. Let's just quickly take the size of nums in n so that we don't have to write it again and again, and then we can change this to n. Right now, see, how are you going to remove this recursion? See, in this recursion, for each index, we are getting the value from index plus 1 after addition and after subtraction. Then whatever is the value that we are getting, we are doing the sum of both these and we are updating the current index. Then that means for index, I need the value of index plus 1, right? But when I will remove this recursion, I won't be having the value at index plus 1, right? So instead, can I say that if I consider this index plus 1 as index, then this index will be index minus 1, right? Here, this is the current index and this is the next index, right? So now I am saying this is my current index, so this is going to be the previous index, right? So basically, if I am at index I will update its value with I minus 1, right? So here, let's remove this. So first of all, let's take the base case. So in the DP, add the index 0 and in the map, add the key 0, we will update it to 1. Now what is this? So see, the first index is telling us the number of elements that we have taken from nums, and this second number is telling us the sum. So it is saying if I have taken 0 number of elements from nums, then in how many ways the sum will be 0? So there is one way, right? We have taken 0 number of elements, so obviously the sum will be 0. So there is only one way in which this is possible, right? So that is why in the DP at this index we are storing as 1, that I have taken 0 number of elements from nums and their sum is 0. So there is one way of achieving that. So this is our base case, right? Now what we will do is that we will run a for loop of I starting from 1 and going less than equals to n and then I plus plus, right? Now inside this, if you see, I said that I will consider this one as my current. So basically this will be I and this index will be I minus 1, right? So nums also has to be I minus 1, right? So my current number, or I can denote it with num. So my current number will be nums of I minus 1, right? And then for updating this ith index in DP, I need the values in I minus 1th index in the DP, right? So I'll run a for loop that for auto sum comma count in DP of I minus 1, right? From the previous, I will take that what is the sum and the count that I am getting, and then in the DP I will update the index I, right? And this will be in the sum I will add the current number, right? So in this I'll update the count, and then at the index I, in the sum I will subtract num and then I will update the count, right? So with this, in the DP, add the index n comma target, I will be having my answer and I can return this, right? So basically, after taking all the elements of the nums, right, then add this target, whatever are the number of ways present, that is going to be your answer, right? So we can just comment this, right? So this is our code now at each index, right? In DP, the first index is telling us that how many elements of the nums we have considered, and the second element is telling us that what is the sum, and the value is denoting us that with these many elements from nums and with this sum, the total number of ways are this, right? So that is why at the end we are saying after considering all the elements from the nums and the sum equals to the target, whatever is the total number of ways that we have got, that we will return, right? Now here also the time complexity and space complexity is still the same, that is n into total sum, right? So let's quickly run and check the code. Yeah, so here we can optimize our space complexity. Now how can we do that? So if you see in this DP vector, we don't have the need of storing all these n plus 1 indices. Why? Because for each index I only need the previous index, which is I minus 1. I don't need I minus 2, I minus 3 indices, right? So what we can do is that instead of taking this entire DP vector, we can just take two vectors, one denoting the current vector, which will be dp of I, and one denoting the previous vector, which will be dp of I minus 1, right? So I'll make the changes here itself. So instead of dp vector, what we will do is that we will take two unordered maps. One will be the previous and one will be the current, right? And then this was the previous one. In the previous, for the key 0, basically for the sum 0, the number of ways will be 1, right? And then inside this, what we'll do, we'll iterate for all the numbers in my nums vector, and then from the previous we will take out what is the sum and what is the count, right? And this dp of I, this has now become current, right? So this we will change to current. Same approach we are following, that we are updating the count in the current map, right? And then once we are done with this, in the previous we should also assign the current, and once we enter inside this, we should clear the current, right? So whatever is current right now, for the next iteration, it will become our previous, right? That is why we are updating previous to current over here. And as soon as we enter for a new iteration, our current should be cleared, right? Because it should now get updated with the help of previous, right? And at the end here, we can write previous. Previous and current, anything can be used here, because at the last iteration, what will happen is current will be having the value whatever it was having, and it will also update previous to the value of itself. Basically previous and current both will be having the same value, right? So current of target or previous of target, anything we can return. Let's return current, right? So now here your space complexity has reduced to 2 into total sum, right? Or I can say it will be equals to the total sum of your nums vector elements, right? Time complexity will remain the same. It will be n into total sum only, but we have optimized our space complexity. So let's submit this code. Let's remove this extra. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.